Boom! Hume here. Welcome to another maths video. In this video we're going to deal specifically with a topic that causes a lot of stress to students all over the mathematical spectrum. This is the topic of logs. Logs, of course, being short for logarithm. So we're going to start by defining what a log is, and then we will use the definition as written out in words to lead us straight into the mathematical equation, which we'll write, of course, using symbols, using letters. Good? So we begin. What is a logarithm? A logarithm is a quantity which represents the power to which a fixed number must be raised to produce a given number. So I will read that again. A logarithm is a quantity which represents the power to which a fixed number, we call the fixed number the base, must be raised to produce a given number. And for our purposes here, we will refer to the given number as the quotient. Okay, so that will give us three quantities to consider. We have the power, we have the base, and we have the quotient. Just remember that the quotient is whatever you get at the end of your mathematical process. Good? So if we have a base and we have a power, and we're raising the base to a particular power. So in other words, we're dealing now in the realm of indices, in the realm of exponents. Good? So logarithm is basically the flip side of exponents. So, and you'll see that a little later. So if we say that we have the base, so we're going to write it out in the words now. The base raised to a particular power will give the quotient. Good? That is the basic equation as given by the definition in words. Good? The base raised to a particular power will give you a quotient. You have in letters now b raised to a particular power, which will give you your q. So b for base, p for power, q for quotient. So let us reconsider the definition. So the logarithm is the quantity which represents the power, p for power, to which the base must be raised to give a particular number which we refer to as the quotient. So in other words, the logarithm is actually the power. Good? So anytime you see an exponential equation, then you know that the power is what we refer to as the logarithm. We'll get to some examples in a bit, so don't worry. Good? Now, at what point does this become logs? Good? We're going to deal with that now. So, we have this particular equation that we were able to derive from a definition that was given in words. Good? We use the concepts, we assign certain symbols to the concept, and we were able to put a mathematical equation. So, we're going again. We know that this here is a log because definition says that the logarithm represents the power, right? So the log is the power, and in fact you will see some places where the log is defined simply as a power or as an exponent, right? Maybe even as an index in some places, right? All three of those words are used to mean the same thing. All right, so this is a log. So if we want to write that in words now, what we're going to do, we say that the log is equal to p. Good? The log is a quantity which represents the power to which a fixed number, the base, must be raised to produce a given number. So if the log is p, the log of what is p? Right? The log of q is p. So in other words, the log of the given number, which we call the quotient. So the log of the quotient is the power. But then this is meaningless if we don't give consideration to the base. In other words, the log of the quotient is the power, but where the power come from? where did the power come from? The power was simply the amount that we multiply the base by itself. So in other words, we raise the base by a particular power to get the quotient. So what we do is we put the base at the bottom here. So the log of Q is equal to P, but it's not just the log of Q in isolation. The log of Q to the base of B is equal to P. So just to reiterate, you have what we call the exponential form on the left side here. Your base to the power of P is equal to Q. Base raised to the power of P is equal to Q, your quotient. Good. And then we say that in a logarithmic form, and we say that the log of the quotient Q is equal to P, the power. But more than just that, we go into further detail and we say that the log of the quotient Q to the base B is equal to your power P. Good. So this is the exponential form. This is the logarithmic form. So we're just going to write that out just so that you can see it. Alright, so this is the, I have to choose the colors, this is the exponential form, and this is the logarithmic form. Good. Right, now is where the session going to get nice, because we're going to use actual numbers now to illustrate the concept of logs. Good. A lot of times in maths, you explain a concept in some kind of generalist terms and people don't get it. But when you use an actual example, that is like, whoa, it suddenly hit home now. Good. So I have every confidence that the next part of this thing here is where it's going to hit home, where we're going to actually use an example to illustrate the concept, and then after that we would have laid the platform to push forward with further work in logs.